Sorry. So actually, I didn't record it. So it looks like the first few lectures will be just without any sounds. That happens sometimes. So maybe for your benefit, I'll just repeat. Just for the name of the site, it's sites.google.com/site.quantum.us. And YouTube under David An is me. So titles are Engineering Mathematics 1-1, 2, etc., etc. Complex Analysis 1, 2, Vector Analysis 2, 3, etc. Theory Analysis 1, 2, something. And this semester, the title will be starting with Engineering Mathematics 2-1, 2, etc. So maybe, so far there are about 20-something YouTube lectures. And my office is second floor 2-226. This is my email address. And if you like to have an office hour or ask questions, you can make an appointment with me by sending an email. But actually, I recommend you to study the lecture notes posted on the website, and maybe YouTube will be happy too. So that's about it. And probably for most of you, the most important concern is what would be your grade, right? Oh. Sorry. So actually, this YouTube will be gibberish. I mean, so I apologize. I have to pay attention to this recording. So was it 대상? 대상, 금상, 은상, 장려상? I think 대상, first prize, second prize, third prize, 대상, 금상, maybe 은상, and 장려상, and participant. So if you get the first prize, 대상, there will be bonus point of 200. Oh. Sorry. So actually, this YouTube will be gibberish. I mean, too much. So I apologize. I have to pay attention to this recording. And 금상. So was it 대상? 대상, 금상, 100 points. 장려상. And 은상, 대상, 50 points. Prize. 장려상, 30 prize. What's happening? Third prize. 대상, 금상, maybe 은상. And 장려상. Something is wrong with this application. Okay. And participant. Okay, I'll change my mind. 금상 get 150. And 은상. So if you get the first prize, 대상, 장려상, there will be bonus point of 200. And you can get free 10 points just participating. Too much? And 금상, and traditionally, students from my class usually get those prizes. And 은상, 50 points. If you work hard and if you get the first prize or second prize, then I think you'll get a very good grade. So any questions?
Something is wrong with
Or
this.
complaints about this bonus point? So,
Okay, I'll change my mind.
so can I say that there is
get
no complaint about that?
150,
Right. So at least you can
and
get 10
Eun상
points by just participating.
100 points,
So managed to get
and
the
장려상 50 points.
and you can get
So that's
free
great.
10 points
policy.
just participating. So any questions about that? So this semester we are going to start with and traditionally students from my class usually get those prizes. So, I mean, if you work hard and if you get the first prize or second prize, then I think you will get a very good grade. So, any questions or complaints about this bonus point? So, can I say that there is no complaint about that? Right. So at least you can get 10 points by just participating. It doesn't matter. So managed to get the 장려상. So that's great policy. So any questions about that? So this semester we are going to start with vector analysis. The first lecture will be about vector analysis. Oh. The first quiz will be September 25. It's because I have to attend some government meeting on that day, so I cannot give a class. So the best possible way is a quiz. So unfortunately, the first quiz will be 2 hours. 2 hours quiz. And you can prepare 2-page trading sheet, A4 size, handwritten. I like to emphasize that part, handwritten. So you have to write your own. And you can bring dictionary. Maybe you need a calculator, but probably not. And for the first quiz, my advice is read the problem carefully. So occasionally I give a number 1 quiz as write your name, but some students wrote my name. It always happens. Even though I keep telling you in every semester, I always tell you that you have to read the problem carefully, but that happens all the time, quite often. So you really have to read the problem carefully. And the quiz problem will be given in English, and you are advised to write your answer in English, but Korean will be acceptable.
the vector so anybody who has learned vector in high school or freshman years, raise your hand, or heard about the vector anyway. Okay, some student heard. Never heard about that, raise your hand. So at least you have heard about the notions. So vector is a quantity that has both magnitude and direction. Well, there are more sophisticated definitions and relativity, but let's just use this definition for a while, because there's another way of defining vectors in terms of a transformation, but that's a little bit very mathematical, and it's just very elegant and nice, but it's not necessary at this moment, at this stage. So we need to have a magnitude. Magnitude you can understand, right? How about direction? For the direction, we need the common reference point. And coordinate. So normally we are using, am I going a little bit too fast? Okay, I will let you copy. And during the break, I will put the attendance list on the table, and I want you to check if whether your name is here or not. Because it always happens that actually once in a while, the students work very hard, attend the class every time, and take all the quiz, got a good score. And then when I was going to give him a grade, it was not listed on the computer. So that actually happened a few times. So after that, I just make sure that everybody checks whether your name is here. But unfortunately, if there isn't the student who did not attend this class, there's no way that he can check, right? Or he or she can check. But at least you will have a chance to check. So I will put here. So during the first break, you can check your name is there. Just check. Oh, maybe it's time to change my iPad. It's been 4 years old and it's getting slow. Okay. So most common coordinate is this x, y, z, and common reference point O. So our space is three-dimensional, so we need the three mutually perpendicular axes. So we call x-axis, y-axis, and z-axis. It's called a Cartesian coordinate. So Cartesian coordinate. And this Cartesian coordinate is actually, the origin is from the French mathematician named Descartes. So Descartes wrote the analysis mathematics in 18th century, I believe, and he first described the coordinate system. So we are following him, and maybe maybe months later, we will learning other coordinate system. But for now, we will be studying Cartesian coordinate. So if we have a vector, and we define the unit axis, unit vector, like a x vector or z vector. Oops. So x is a unit vector. Unit vector means a vector with a length of 1. And we are going to define the length a little bit later in x direction. Y hat is called the hat. Unit vector in y direction. Z unit vector in z direction. Then any vector A, say A, any vector A can be represented by the component in each direction. Or we have another vector B, Bxx, Byy, Bzz. So up to now, it may be quite easy for you to follow. So vectors can be added. So we can define A plus B. Bzz as a component by component addition with a fixed axis. So ax plus bx x, ay plus by y, az plus bz z. Vectors can be multiplied by a constant. So C is a real number. It can be complex, but let's focus on real number. C times AXX, AYY, AZZ, CAXX, CAYY, CAZZ. So in both addition and multiplication by constant, we like to note that this direction unit vector is fixed, right? So maybe in two-dimensional, we can do some example. I think still some student needs copy. So if we have a, oops. Sorry. For example, just consider two-dimensional vector, x, y. This is a vector A. So say vector A is 2x, 3y, and vector B is, say, here, 2x plus y. Then A plus B will be 2 plus 2 is 4, right? Very good. 3 plus 1? 4. So maybe I need to draw it again here. 1, 2, 3, 4. This is x. 1, 2, 3, 4. Y. So A was 2 plus 3 here, right? That's A. B was here. A plus B was 1, 2, 3, 4, and 4. Here, right? And actually this is something, this is like this. You can parallel transport this vector into this. This is A, B. So this is actually A plus B. So for practical purpose, you can parallel transport this vector into here, and then just draw A, B, then this will be A plus B. If 2A I think I'm a bit sloppy. So maybe after lunch I may be a bit sleepy. So it's twice of 2x plus 3y is 4x plus 6y. So 4x 1 to 6. So this is actually, this is 2a, right? So just extend a by a. So vectors can be added. But also vectors can be multiplied, but then you need to define the multiplication rule. The first vector multiplication is called inner product. You have an A vector, B vector, and if there is angle between two vectors, A dot B is defined as A, B, cosine theta. So using this definition, what is the inner product between head and head? So what is the angle between x head and x head? The angle is 0, right? And cosine 0, 1. And this head vector is defined with the unit length. So this is equal to 1, right? So what is the angle between x and y axis? 90 degree, right? Or pi over 2. And cosine 90 degree is 0. X dot z. The angle between x-axis and z-axis is again 90 degree, right? So cosine 90 degree, 0. And y dot x, same, right? Y dot y, 1. Y dot z, 0. Z dot x, 0. Z dot y, 0. C dot z, 1. So we have this relation. Then we can actually define the inner product between A and B the following way. So A dot B is AXX, AYY, AZZ, inner product, PXX, PYY, PZZ. Then we have a 3 by 3, 9 components, right? But most of the inner product between x and y are 0. So only surviving term is x dot x, y dot y, z dot z, right? So only non-zero component is ax bx, ay py, az pz. And using this inner product, we can actually define the magnitude. So magnitude is defined in the following way. So magnitude of the vector A is defined as square root of A dot A, which is square root of AX square, AY square, AZ square. So if A is given by x plus y plus z, B is given by x minus y plus z. So what is the angle? Over theta. So we can actually find the cosine theta, right? So A dot B is magnitude of A, magnitude of B, cosine theta, and which is also same as AX, BX, AY, BY, AZ, BZ, and here square root of 3, right? This B is also square root of 3. AX, BX is 1, minus 1 plus 1 is 1, right? So 3 cosine theta equal to 1, so cosine theta is 1 over 3, and theta is arc cosine 1 over 3. So I don't know, if you have a calculator, you can actually calculate this number. So maybe in the quiz, if I ask to find the angle, then you may need the calculator. The engineering calculator, right? And next vector product is multiplication vector product, but that's a little bit complicated. So maybe you can take a break for now because start recording. There's a second kind of vector multiplication between the vectors called the vector product. Sometimes called cross product, which is defined the following way: A, B, which is mutually perpendicular to each other, A cross B. So following the left-hand rule, A, B, and C. So this is A, B, A cross. This is A cross B. Looks like a hand? More like a rabbit. Or something. So it's like A, B, and C. A, B, A cross B. So it's defined as following. The magnitude of the vector product is A times B times sine theta. So sine theta is actually this area. An interesting thing is if you change the order, then you have the opposite sign. So let's check the component first. So what is the angle between x hat and x hat? 0. And what is sine 0? 0, right? X cross y. So x cross y is z, right? X cross z. X, z, x cross z, this way, right? So minus y. Y cross x minus z. Y cross y 0. Y cross z x, right? So x, y, z. So this way, right? Y, Z, X. Z cross X, X, Y, Z. So Z cross X is Y, right? Z cross Y minus X. Z cross Z, 0. So using this relation, you can actually calculate A cross B. So vector product is a little bit more difficult than calculating the so if we have A, A is given by A X, A Y Y, A Z Z, B is B X X, B Y Y, B Z Z. How many of you are taking a class course on electromagnetic theory? 전자장? How many of you are taking 전자장? Maybe half? So I think we will be starting with vector analysis in 전자장, so it will be helpful for your other class too. So A cross B is AX X. This is a little bit difficult subject, so I'm going to write down fully. Cross BX X, BYY, BZZ. The 3 by 3 we have 9 components, right? So AX, BX, X cross X, AX, BY, X cross Y. So you multiply. Start with this X plus X, X plus Y, X plus Z, plus AX, BZ, X cross Z, plus AY, BX, Y cross X, AY, BY, Y cross Y, AY, BZ, Y cross Z, plus AZ, BX, Z cross X, AZ, BY, Z cross Y, AZ, BZ, Z cross Z. So what is X cross X? 0. Y cross Y, Z cross 0. X cross Y, Z, right? Okay. X cross Z minus Y, Y hat. Y cross X minus Z hat. Y cross Z, X. X, Z cross X, Y, Z cross Y, minus X, right? So actually, it may be easy to remember if this way. Counterclockwise plus, clockwise minus, right? So X cross Y is Z, Z cross X is Y, Y cross Z is X. So I can factor with X. What is X? AY BZ minus AZ BY Y AZ B where is Y? BX minus AX BZ C AX BY minus AY BX, right? Bit messy, but it's doable. So, not too difficult, right? So let me just summarize. AYBZ, AZBY. So A cross B, X, AY, BZ minus B, AZ, AZBY, Y, AZBX minus AXBZ plus Z AXBY minus AYBX. Let me just compare with the previous result. YBZ, right, correct. And actually, there's something familiar from the spring semester. Anybody remembers determinant? So it actually is this X, Y, Z, AX, BY, AY, AZ, BX, BY, BZ. So it looks like a determinant, right? Should be 3 by 3 determinant. The only difference is you have a vector hat in the first row. Or we can actually represent by component. So let's say 1 is X, 2 is Y, let's write down. If we write down X, Y, Z as 1, 2, 3, for convenience, let's say if we write down 1, 2, 3 as X, Y, Z as 1, 2, 3, then A cross B, X component is actually A cross B, component 1, can be written as AYBZ minus AZBY, A2B3 minus A3B2. So let's just simplify. I'm simply denote X, Y, Z as 1, 2, 3 for convenience. Then the X component can be written as the component 1 component of this closed vector, then AYBZ minus AZBY can be also written as A2B3 minus A3B2. So let's just assume, let's just make a promise. So 1, 2, 3 is just XYZ. Then A cross B 2 is actually A cross B Y component. This actually is A Z BX minus AX BZ can be as A3 B1 minus A1 B3. And you will see why I'm doing this. A cross B Z component is A cross B. Actually, you can write it 3 is A Y AX BY minus AY BX is A1 B2 minus A2 B1. So we can either XYZ or 1, 2, 3. Then we can use a Levi-Civita symbol. How many of you remember Levi-Civita? Or even combination. Or odd permutation. Otherwise, so that means we have 1, 2, 3 in this way. 1, 2, 3, 2, 3, 1, 3, 1, 2 is 1. Minus 1. So that means epsilon 1, 2, 3, epsilon 2, 3, 1, epsilon 3, 1, 2 is plus 1, epsilon 3, 2, 1, epsilon 2, 1, 3, epsilon 1, 3, 2 is minus 1. Otherwise, 0. So epsilon 1, 1, 2 is 0. Then A cross B, I's component, is sum over JK, epsilon I JK, AJ BK. So actually we learned this in spring semester when you're studying the determinant. So let's try two examples. A cross B, the first component. So if I is fixed as 1, then JK should be 2 or 3, right? Otherwise, they are 0. So only possible combination is epsilon 1, 2, 3, A2, B3, epsilon 1, or J3, K is 2. 1, 3, 2, A3, B2. So the first component A1 to 3 is plus 1, right? So A2, B3. Epsilon 1 to 3, 1, 3, 2 is minus 1, right? So this is A3, B2. According to my experience, usually students faces so-called mendung when I introduce the Levi-Civita. But it's just a notation, so it won't be too difficult. But so, I mean, let's just do the example together because, I mean, this is probably a very difficult concept to digest. So, any questions? It's too easy? Okay. So let's practice again. So A cross B 2. So same as this, epsilon jk, epsilon 2 jk, right? As before. A j b k. So the first index is fixed. So j has to be either 3 or 1, right? So if j is 3, k is 1, or j is 1, k is 3, right? So the only possible combination is epsilon 2, 3, 1, a3, b1, plus epsilon 2, 1, 3, a1, b3, right? So this is 1, 2, 3. This is plus, this is minus. So 2, 3, 1. This is minus, right? 2, 1, 3. This is 2, 1, 3 is let me see. 2, 3, 1. This is plus. Sorry. 2, 1, 3. 2, 1, 3 is minus, right? So this is minus. So this is A3, B1 minus A1, B3. Or you can write down this way, XA cross B. Y component is actually AZ, BX minus AX, BZ, right? YX. We can do the same thing. A cross B, 3 component, same. Sum of JK, epsilon 3 JK, AJ, BK. So 3, so JK can be 1, 2 or 2, 1. So epsilon 3, 1, 2, A1, B2 plus epsilon 3, 2, 1, A2, B1. So this is 3, 1, 2, 3, 1, 2, plus, right? So this is plus. 3, 2, 1. 3, 2, 1 minus. So this is A1, B2 minus A2, B1. Or A cross B, Z component is AX, BY minus AY, BX. So there were 3 ways to calculate the vector product. One is just multiply them together. Second, use the determinant. Third method is use this Levi-Civita symbol. So why bother? Why do I do this very complicated mathematics? there must be a reason, right? Because there is a reason that I introduced this little bit difficult concept. I like to do like make a copy. Oh, you still. What if we have C? A cross B cross C. 3-vector problem. So actually you can do that, right? So let's say this is I's component. Then what do we do? A cross B cross C, I's component, JK, epsilon JK, AJ, B cross C, K component, right? JK, epsilon, IJK, AJ. This must be K's component, so we can have PQ, epsilon K, PQ, PP, CQ. PQ, epsilon IJK, epsilon K, PQ, AJ, PP, CQ. We can write this way. This is same as epsilon PQK. For example, epsilon 1, 2, 3. So epsilon 1, 2, 3 is same as epsilon 2, 3, 1, right? 2. So you can move twice. So we need to have epsilon IJK, APQ, right? Be more difficult. So JK, PQ, epsilon IJK, epsilon PQK, AJ, PQ, PP, PP, CQ. Let me double check. So we can actually separate the summation because AJ, BP, CQ doesn't have any K, right? So let's make a J, P, Q, and K, epsilon IJK, epsilon PQK, AJ, BP, CQ. So let's do this calculation first, this summation first. So I'll write down the answer first. Epsilon ijk, epsilon pqk is delta ip, delta jq minus delta iq, delta jp. So Kronecker delta is given by this ij 1 0. Otherwise, this is a name called Kronecker delta. So if you've taken my class in the spring semester, you also know about this, right? It's Kronecker delta.
So take a look, K is common, right? So when ij, so PQ must be ij or ji, right? Because K is common. So when PQ is ij, then the same order, then this plus, right? Otherwise it's 0. When PQ is opposite order, like ji, then when this is plus, this is minus. When this is minus, this is plus. This is minus sign. So you can have this.
So I'm going to show this property a little bit more using detailed expansion. But maybe it's better to remember this formula. A bit difficult to follow. So why we are doing this, right? A cross B cross C is this. AJ, BP, CQ. Let's see this. Oops. K, epsilon ijk, epsilon pqk. So we don't know which k is possible. So let's say epsilon ij1, epsilon pq1 plus epsilon ij2, epsilon pq2, epsilon ij3, epsilon pq3, right? So k can be either 1 to 3. So that's the formula. So let's assume I equal to 1, j equal to 2. What happens? In that case, one, 2k, epsilon pqk. So k has to be 3, right?
If we fix I equal to 1, j equal to 2, then K has to be 3. So all this term will be 0, right? So only this survives.
Has to be 0. Other terms will be 0. So this is simply epsilon ij3, epsilon pq3. So only possibility is p is equal to 1, q is equal to 2, right? Or p is equal to 2, q is equal to 3, right? Or 1. So either 1, 2, 3, epsilon pq3 is plus 1 when p is 1, q is 2, minus 1, p is 2, q is 1, right? So when p is 1, q is 2, this is plus 1. And when p is 2, q is 1, this is minus 1. So it can be written as this way: delta 1p, delta 2q minus delta 2p, delta 1q, right?
So this is same. So this expression is same as this. When p is equal to 1, p is equal to 2, this is plus 1. When p is equal to 1, this is 0, right? So it does contribute. When p is equal to 2, this is 0, but this is 1. So this expression can be written down in this way.
And so we can consider two other cases too. The original formula. So let me just repeat it again. K epsilon I j k epsilon p q k is same as epsilon I j1 p q1 plus epsilon I j2 epsilon p q2 epsilon I j3 epsilon p q3. Now, if we set I equal to 2, j equal to 3, then what? K has to be 1, right? So in this case, epsilon I j k, epsilon p q k, simply the first term, I j1, p q1, right? Which is epsilon 2, 3, 1, epsilon p q1. So this is plus 1 minus 1. When p is equal to 2, q is 3 is plus 1. Otherwise, p is equal to 3, q is equal to 2 is minus 1, right? So we can write down simply this way: p2, q3 minus delta p3, q2 delta. So we can, so in general, so we can say that k epsilon I j k epsilon p q k is simply delta I p delta j q minus delta I q delta j p. So we need to go. The reason why we are doing this is the following. So A cross B cross C. I's component is actually J, P, Q over K, epsilon I, J, K, epsilon P, Q, K, A, J, P, P, C, Q. So this is basically J, P, Q delta I, P delta j q minus delta I q delta j p, right? So we have this. P is I, Q is AJ. So sum over J, AJ, CJ PI minus J AJ PJ, CI, right? AJ, CJ, PI minus CI, J, AJ, PJ. So this is simply A dot C. This is A dot B. So BI CA minus CI A dot B. So using this, A cross B cross C can be written as following: B C A minus C A B. Oh, actually, I have to put this way. This is AI, CI. This is minus AI, PI. Because J is not same as I, right? So this term must be actually only two components. Say if B is 1, J is 2, 3, right? So it's A dot C minus AICI. And this term actually is A dot B minus AIBI. But this cancels each other, so it turns out to be this. So we have the final formula. So we have A cross B cross C, B C A minus C A P. And actually you can prove this using the hard way. That is B cross C or X component P Y C Z, right? P Z C Y plus Y P Z C X minus B X C Z Z B X C Y minus B Y C X, right? So you can do this way: A cross B cross C X, right? So A Y, right? And what do you have? This is C, right? A Y B cross C, Z component of B cross C. So Bx Cy minus By Cx minus X, Y, Z, AZ, right? Y component, X, Y, Z, Y, Z, ZY, Px, Pz, Cx minus Px, Cz. And for the Y component, well, if you're just patient enough, you can do this. Y, Z, right? So AZ and AZ, P cross C, X. So BYCZ minus BZCY minus AX YCX YZX. So Z, right? PX CY minus PYCX. Okay, no problem. AY P cross C Z component, right? So BX CY minus BYCX minus A X, right? C Y X A X Y component BZ CX minus BX CZ. Oh, right. A X, right? CX, oh, Y. Then I made a mistake. So, okay, Z, X, right? So Y, PZ, CX minus BXCZ, A, Y, X, BYCZ minus BZCY, right? Okay, let's just check the first component, this. X component. A cross B cross C. X component is, okay, PX AY CY plus PX AZ CZ minus CX AY PY plus AZ BZ, right? So PX, we can add this AY CY AZ CZ minus CX AX BX plus AY BY plus AZ BZ. We just add the same term and delete the same thing, because if you take a look, this term and this term is the same, right? So we can add something and add the same thing. We haven't changed anything. So this is basically Px A dot C minus Cx B dot A, right? OAB. So we obtain the same result by directly expanding the cross product 3 times or using a little bit more complicated, but just using Leibniz symbol, you can get a very intuitive result. Wow. So any questions about this? So you are familiar, now you can, if I ask you to do this calculation in a quiz, can you do that using Leibniz or whatever? Okay, good. So I guess for some of you, I mean, if you have taken my class in the spring semester, then I think you'll be familiar with the Leibniz symbol, and then won't have that much difficulty to follow my class. But if you're new to this class, then actually we'll have some time to digest the material. So maybe this is first class, so maybe stop here today. And I will let you give the time to digest the material, and we'll continue. Next week I'll continue after that. So any questions?
빼.
어, 어디 되겠지?